share my screen.
Probably they need to find a workaround for that. I mean, another way to solve that.
I know. I know. If we had built the Meetup app, we wouldn't be having this problem. Seriously though. I know it's like I'm joking around and laughing and stuff, but seriously, dude. They definitely need better talent, clearly. Can you see my screen? No, let me.
Not you.
All right, there we go. Cool. Can you hear me good?
Yeah.
All right, cool.
Really.
So the problem is longest palindromic substring given a string S, return the longest palindromic substring. So in this first string here, we have BAB, we have ABA, and those are both of length 3. We also have just A, like each character individually is a palindromic substring too. And then in the second string, we have obviously each independent character, and then we also have the 2 in the middle for B. So the length of the string is going to be anywhere from 1 to 1,000, and S consists of only digits and English letters. So it's going to have numbers or letters. And the first solution we're going to go through is just the brute force. So in this one, basically what we're doing is we're checking, let me just take an example, is we are checking, so if this is our string, we're going to have an I, oops, and we're going to have a J, and we're going to set I is going to be the outer loop, J is going to be the inner loop. We're going to set J to equal I because we want to include this palindrome right here. We want to include the single characters just in case there are no doubles or triples or anything longer than 1. We want to make sure we're getting every one individual character as well. So we'll create an external function, just is palindrome to check. And this function will basically just split the string, convert it into an array, reverse the array, and then join the array. And then we'll compare the original palindrome with the reversed palindrome. And if they're equal, then it is palindrome. Very, very simple function. And we'll have a max length which starts as 0, and we'll have a longest, which just starts as an empty string. So we'll iterate over it. Like I said, the first thing we're going to do is we're just going to find out what the substring is. So let substring equals s dot substring I plus I plus 1, or I, and then the second argument is j plus 1. So in this case, it would be 0 to 1. It would take B, and then we'd move J to the next one. So it would take this one would be the substring, and then we move J here. We take this as the substring, move J here. Take this as the substring, move J here. Take the whole thing as the substring that we increment I. Now we start over, starting J where I is, and do the same thing. So we're literally checking the palindromes for each and every character inside of here, and then we're just checking if it is a palindrome and the length of the palindrome is larger than our max length, so our existing longest. Then we'll replace our max length with the length of our new longest palindrome, or replace longest with the substring, and we'll continue. So I'll go ahead and write just a little bit of pseudocode here. Create is palindrome function. Once we create the function, we'll create variable to store max length. We'll create variable to store longest substring, and then we will iterate over the string one character at a time, and then we'll expand current substring by moving J to the right while keeping I in the same position. Once we're inside of J, we're going to store our new substring inside a substring variable. We're going to check if the substring is a palindrome with our function, and we're going to check to see if the substring's length is greater than max length or max len. And if it is, then we're going to store substrings length and max length, store the substring in longest, and then at the end we're just going to return longest. That all makes sense, right?
Yeah.
So you want to type any of this code? Feel free if you want.
Sure. User the link.
Oh yeah, not bad. Here we go. Cool. I'll go ahead and just start typing because I do want to get to the next problems too, so, or the next solutions. So in this case, we're just gonna return string equals string dot split dot verse dot join. So in this case, if the string that was passed in is equal to this, then we're good to go. Perfect. Let I equals 0. Well, I is less than s dot length, I plus plus. Let j equals I. There we go. Oh, we deleted some pseudocode.
Yeah, I'm gonna paste that. Word.
Oh, you got it?
Let me.
There you go.
Yeah. I think that.
That looks good. So that's our substring. palindrome substring and substring dot length is greater than max length, then we'll do that. And longest substring. There we go. Is substring dot length equals max length. If it is, then we will store the substring's length inside max length. We'll store the substring inside longest, and then so that should be good for that solution. As brute force as it gets. This right here is O of n, and then this is O of n, and this is O of n, and then we do is palindrome inside of this. So this is actually O of n cubed. So horrible.
Yeah.
O of n cubed, man. So definitely don't like this solution. Though if you look at the problem is only 1,000 characters tops. So you're probably pretty good with this, honestly. But if it went up to like 1,000,000 or 1,000,000,000, yeah, you're going to start running into some real problems with this solution. So let's go ahead and test it out. There we go. So we got BAB, BB, and then I created some longer ones, and these are correct as well. They start from ZZ, YY, XX. It's basically the alphabet backwards. Forwards, then backwards. And then this one is the word level with just some characters on the outside. So that is correct. We're good to go. We will go ahead and do the expand around center solution now. So this one's pretty similar.
The dynamic programming solution?
No, this is expand around center. So we'll go ahead and we'll use this again. So this one is going to be very similar to the last one because we're going to iterate over every character of the string. The only difference is we're going to iterate over every character of the string, and then for every character of the string, we're just going to have a left pointer and a right pointer, and we're going to expand outwards until the characters don't match anymore. So if we start with B, let's just say when we first start, we're going to have I, we're going to have left, oops, and we're going to have right. So at this point, we're going to execute, we're also going to have I plus 1 to account for evens. So the first thing we're just going to check to make sure that the length of the string is greater than 1. If it is, then we'll continue with the function. If it's not, we'll just return the string. We'll create a start and an end variable just to keep track of where the longest palindrome starts and ends. And then once we have that, those two variables created, so we're gonna have like a start equals 0 and an end equals 0 just to start off with. Then we can start iterating over it. So the first thing we're going to do when we start iterating over it is we're going to run expand around center on I and expand around center on I plus 1. So we're constantly always checking for our odd palindrome, and we're checking for our even palindrome. Expand around center, passing in I and I, is going to give us the value for any palindrome whose center is I, and then when we pass in I and I plus 1, it's going to give us the longest, or the value of the palindrome whose center is those two values. So this accounts for both odd and even strings. And then once we get back the odd palindrome and the even palindrome, then we are able to compare those two values. Whichever one is greater, then we compare that max length and see if it's greater than n minus start. So the start and end values we have, if it is greater, then we go ahead and we reset the start and we reset the end. So let me go ahead and just run through this one real quick a little bit, and you can see how it works. So once we start our for loop, we run expand around center on I. And because once we pass in the string, and we pass in I and I twice. So we pass in I and I for left and right because this is an odd. And then once we get into the function, we're going to, while S left and S right are equal, then we decrease left and we increase right. And so because on the first one, left goes outside the bounds of the string, then we automatically return. We just return 1. So what we're actually returning is just right minus left minus 1. I mean, yeah, right minus left minus 1. So at that point, we would have 1 minus 0 minus 1. So we'd return 0. So we'd return 0 from that right there. Let me go ahead and just draw this out a little bit. So while the left and right pointer are within the bounds of the string, and while the S left and S right value are the same, then we'll decrement left, increment right, and then we'll just return the length of the palindrome. So we'll do while left is greater than or equal to 0, and right is less than or equal to s dot length, and s dot left equals s dot right.
Right.
Let me know if you have any questions too.
It needs to be less than or equal than s dot length minus 1, or we are doing, I think it needs to be less or equals than s dot length minus 1, because we are going to access another position outside of the boundary of the string.
True. And then just return right minus left minus 1. And then we also run it on I plus 1. So in this case, we would enter into this expand around center. We'd pass in the entire string. We have left being passed in as left being passed in as I, and I plus 1 is right. So the values change for this execution of it. And since this is supposed to be the center, we come in, we see left is still greater than 0, right is less than s dot length, but s dot left is not equal to left dot or s dot right. They're actually different values. So we never execute this. We do 1 minus 0 minus 1, length equals 0. And then we go ahead and move I. So on the first one, on this A right here, we're checking for centers. The left and right are both on I. We enter this right here. Left is greater than 0. Right is less than s dot length. They are equal because they're both pointing to A. So we go ahead, decrement L, increment R. They're both still the same. And s dot left is equal to s right. And so we continue with this loop right here. So we go ahead and decrement that, increment that. And now we get to the point where left went outside the bounds. R is, this one's true, this one's false. And so we break out of it right there. We return 0, 1, 2, 3. 3 minus, we're outside the bounds. We're at -1. So 3 minus -1 is 4. Minus 1 equals 3. So the length is 3. I think I calculated the previous ones wrong too. We would be, I think I calculated it as 1 minus 0, but it was actually 1 minus -1, which would give you 1 plus 1, 2 minus 1 equals 1. So the previous values were actually 1 each. And then you continue iterating over it, just checking for the odd palindromes, the even palindromes, and then you just return substring start and n plus 1. So we'll go ahead, let me go ahead and just jot out some pseudocode for this. Does that all make sense though?
Yeah.
Okay, cool. So if the string,
Just have one note. You're going to start for the string with an odd length from I. I mean left equals to I and right equals to I, and for even substring with even size with I, and for the left and for the right I plus 1.
yes.
Okay.
Yep. So we'll go ahead, create a variable to keep track of the beginning of the longest palindrome. We'll create a variable to keep track of the end of the longest palindrome. We'll iterate over each character of the string. We'll execute expand around center for odd length palindromes. In this case, like you said, center is at I. Then we'll execute expand around center for even length palindromes, and in this case center is at I and I plus 1, because for evens we have actually 2 characters as the center. Then we determine which substring of the odd palindrome and the even palindrome. Odd or even palindrome is of greater length. And then, so with like a max length variable or something, if the max length is greater than n minus start, and then we do a couple things in here. Then this is where this took me a little second, because we're at I is our center. I is our center here, but I had to account for even as well. So to find the start value, if the max length is greater than n versus start, I took I as my center, and then I found out what half of the max length was. So if the max length was 7 and I was at the 10th position, then I would do I minus 7 divided by 2. So I'd take, like, if the max length was 7, I would subtract 1 from that and divide it by 2. So if the start position is at 10 and the length of the string is, or if I is at 10, the center, so let's just say, let's just say I is at 10 and we have a length 7, then I need, for my start, I need to put so basically start, I need to start like half of 7 before I, and end, I need to end half of 7 here, since I is our center. So I just took our max length. In this case, for the start, I subtracted 1 from our max length, so 6, and then divided by 2, got me 3. So you'd start at 10, 9, 8, 7. So you'd start at index 7, and then you would end at max length. So 7 divided by 2, floored. So 3.5 going to 3. So you'd end at 13. So you go from 7 to 13. And 7 to 13 includes 7, 8, 9, 10, 11, 12, 13. So 7 characters. And so let me go ahead and do set start as the current position of I minus max length minus 1 divided by 2 floored, and set end as the current position of I plus max length divided by 2 floored, and that would give us the end. And that's basically our for loop, and then we just return the original string with substring method passing in start and n plus 1 to make sure that we actually capture that last one too. So it'd be like, if you just do n, then it won't capture that last one. It'll end like just before the last one. So there we go. Yeah, you could go ahead and type the code out if you want to give it a shot.
Okay.
Do you have any questions on it?
Just for this condition, I mean, you're going to do this while this works for odd and even.
Mm-hmm.
size of the substrings?
Yeah.
I mean, yeah. Okay. Okay.
Yeah, you could test it out if you want. I tried it out on a couple examples and it worked for all the ones I did, at least. The dynamic programming one is where it's going to get fun. These ones are pretty straightforward, though, right?
Yeah. I was thinking on the dynamic programming, and you mentioned something like it sounds like a base case, or I mean, basic part of the dynamic programming for that case is when you have just one character. So in the memo, the diagonal is going to be for each character is going to be one.
Yeah. Yep.
Yeah, I was just having that idea from that you mentioned that before on the brute force solution.
Yep. Yep.
That was interesting. Yes. Keep track.
I think this one ends up coming out to O of n squared time O of 1 space. So this one's actually not too bad, actually. From what I heard, this one is accepted from interviewers.
Not the NQ.
Yeah, I heard that interviewers will accept this one.
The expanded.
Expand around center. Yeah, they'll accept it. Because the dynamic programming is less efficient. It's good to know just to like understand dynamic programming and also apply it to other problems in interesting ways. So it's nice to know and understand, but it's less efficient than this one. And then nobody expects you to know Maneker's algorithm unless you're specifically applying for like an algorithm role where you're designing algorithms, you know?
Oh yeah.
So this is like really the best it gets as far as this problem goes, unless like unless you're applying for a job. So with specifically algorithms, so
Unless you are, I don't know if Google is still mm, doing some interviews with this kind of optimizing the algorithm. I mean, searching the best candidate with these kind of skills. But I think it's outdated or not. I don't know what to say on that.
yeah, I think it's important for you to have like system design skills too. Like programming skills just isn't good enough anymore, you know?
Yeah. Yeah, it's not.
Yeah, you need so much more than just programming skills, you know?
Yeah. Also, you need to have soft skills
Mm-hmm.
because they just search for people with also can work with teams. Soft skills are important.
Yeah. So true. Mhm.
Um,
Yeah, this part was a little tricky for me.
yeah, I see that. Um, it's something like you are defining the limit for the left
Mm-hmm. Yep.
eye.
Mm-hmm. Yeah, that's exactly what I got.
Yeah.
I plus max dot length. Yep. Yeah, I didn't subtract one from this one. That didn't work for me.
In some way, it's like similar to some part of the manager algorithm. Yeah, just this part.
The monikers.
Managers. Yeah. So
Yeah, monikers is I'm figuring it out, man. I'm still like working through it to just really understand it, but yeah, it's a doozy for sure. Let's test this out.
yeah.
I is not defined. Oh,
Oh, that's index. Okay.
oops.
I think I can assemble this index. This. Yeah.
Are you using I somewhere else? Let's see. Save it. I is not defined at line 57. Oh, my bad.
Oh, come.
There we go. ABA, BB. Yep, perfect. Cool, cool. All right, cool. We'll hop to the dynamic programming one now. I'll go ahead and I commented out these right here. Instead of actually going through it step by step, what I'm going to do is I'm actually going to just type the code out step by step and make it make sense, and I'll show you in the command line. So the first thing we're doing is very similar to all the other ones. We are checking to see if the length of the string is 1 or less. If it is, just return the string. So if s dot length is less than or equal to 1, return s. Simple enough. In this one, for some reason, I created the length variable. So let's just say create length variable to use throughout the problem. And so we just do s dot length. We have that to use. And then, so basically what I want to do is I want to create an array to represent the string. And so the interesting thing about this array here is, let me go ahead and create the array, and then I'll break it down for you in the command line. So let's say we'll just create the 2D DP table to store palindrome information. Const DP equals array from, and then we're passing in an object to create the length of n. And we're passing in the function so that each one of the elements actually contains its own array of n length. And we're going to fill it with zeros. Before, I actually had a version where I filled it with true and false, but it was so much more information if you filled it with 0. So now I'll go ahead and actually, I had a function. Do I have that function in this file? Yeah, okay, print grid. Perfect. All right, so this makes it way cleaner. So we'll go ahead and do print grid here, and we'll pass in our dynamic programming grid. And let's just see what it looks like now. So if I run, oops, there we go. So we have a grid filled with zeros. Just like in this right here. And the example I'm using in this one is just this string right here. So we have 1, 2, 3, 4, 5, 6, 7 characters. And if you look at my command line, you can see I have 7 characters across, and I also have 7 characters down. So the interesting thing about this is when you're looking at the first array, this represents the entire string. So if we look at our entire string, we have 7 characters. This first array represents the entire string. The second array represents only the entire string minus the first character. The third array represents the string minus the first 2 characters. The fourth represents the string minus the first 3 characters. And so as you move down or through the matrix, lower into the matrix, they actually represent less. So the most information is right here. The most information you're representing actually the most right here. So like in this line right here, let's just say this entire string is a palindrome, perfect palindrome with 7, then we end up having a 7 here. And let's say that actually just the whole string except the first character was a palindrome, we end up having a 6 here. And same thing. If this whole thing was a palindrome, we'd end up having a 5 here. If this one was a palindrome, the last 4 characters was a palindrome, you'd have a 4 here. If the last 3 characters was a palindrome, you'd have a 3 here. If the last 2 characters was a palindrome, which it is in this one, so we'll actually have a 2. This will be a 1. This will be a 2. Now, I'm going to show you something. The next line of code that we're doing is we're just searching for all palindromes of length 1. That's what we want to do first. We want to fill this grid with all the palindromes that are of length 1. So let's go back up here really quickly. I'm going to comment out this print grid, and I'm going to go ahead and let's just say create a start variable to keep track of our longest palindromes start position. This is going to start as just position 0. Then we're going to create a variable to represent the length of the longest palindrome. This one we know that the string is of length 1, so we know already that this is going to be at least 1, because if we passed here, we know this is going to be 1.
Yeah.
And then what we do is we just iterate over each character of the string, storing its storing the value 1 in the dpi position. So like I said, when we were looking at this, this represents the entire string, this represents the string minus 1. So after this for loop, we're gonna have a 1 here, a 1 in the 0 0 position, a 1 in the 1 1 position, a 1 in the 2 2 position, a 1 in the 3 3 position, a 1 in the 4 4 position, 5 5, and 6 6, because we're literally just iterating over the string. And so we'll do for let I equals 0 while I is less than n, I plus plus, and then we'll just do dp I equals 1. And now let's run the print grid. So you can see now if we print the grid, we have 1s just across, because this is just saying if we're looking at the first character of the entire string, then the first character is a palindrome. If we're looking at the a string with the first character sliced off of it and we have just this, then we're still looking at the first character. Then if we're looking at the first character of the string with the first 2 elements or characters sliced off, we're basically just analyzing each character one by one. But the way we're moving through this grid is we're moving from the entire string to the string minus 1 to the string minus 2 to the string minus 3 minus 4 minus 5 minus 6, and we're left with the last one here. So now what we're doing is, if you look at the string we have, it's A B A B A B B. So now we want to check to see if there's any palindromes with 2 characters in a row. In this string, we have 2 characters in a row on the last string. So let me ask you this. Given this grid that we have, where is that 2 going to show up?
Where's, I think, on the one row before the last row. I mean,
This
yeah,
one?
that one.
This one here.
On the last, previous to the last column. This is going to start from that.
Exactly. Exactly. Because very similar to when we iterated through 1 by 1. Now we're going to iterate same 1 by 1, but we're going to be doing 2 at a time. So we're going to do AB, then we're going to do BA, then we're going to do AB, BA, AB, BB, and when we get to this, now since I is equal to 0, 1, 2, 3, 4, 5, since I is equal to 5, then the changes we make is in the 5th index of our grid. So we can determine which row we're modifying by the I position of the character. Whatever character is being pointed to by I, that's the row we're editing, basically. So with this one, we'll go ahead and we'll do checking for palindromes of length 2 by iterating over the string and comparing I to I plus 1, and if they are equal, then we are just going to set our grids I and I plus 1 position to 2. Then we'll set our start to equal I, because that's our new starting position. And then we'll set our max length to equal 2 as well. So we'll go ahead, let I equals 0, while I is less than n minus 1, because now we're checking 2 characters. So instead of doing all the way to n, we just do n minus 1, because if we're checking 2 at a time, where that last character is just doesn't even have a second character to check. And if si equals si plus 1, we'll set our dp I plus 1 equals 2. Then we'll set our start to equal I, because wherever we catch that double, that's where that's the index that our palindrome is starting. And then we're setting our max length to 2, because any palindrome we find within this for loop is going to be of length 2. And then if we go ahead and run print grid on our DP grid, like you said.
Nice.
So the 2 ends up right there. Now the interesting thing about the next one is when you're checking for lengths of 3. This one I like this one. I like it. It's a little challenging to break down and explain. So basically what we want to do though is we want to add palindromes of length 3 plus. So now with this loop, we're going to cover all other lengths, basically. So we're going to go from 3 to n. So we're going to do let now length equals 3, because this is inside here is going to be all palindromes of length 3, while length is less than or equal to n, and then length plus plus. And then inside, we're just going to iterate over the entire string, comparing first and last character of length substrings. And so let's go ahead and just do this example really quickly. So at this point we have here, 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 here. We got that 2 there. And so let me go ahead and create the for loop real quick. So let I equals 0. We're always going to start the first character, while I is less than or equal to n minus length, because we're going to cut length off the n, because we know we only have to go certain distance. And then I plus plus. Now the first thing we do when we enter in here is we want to find like the mirror of I, right? So, and that's j. So we'll just do let j equals I plus length minus 1. And so let me do the example here. So right now I is right there in position 0. We want to find the mirror of I if we're looking for length of 3. So we would do length, which is 3, plus I, which is 0. So 3 minus 1, that's position 2. So 0, 1, 2. And our j ends up right here. And so basically what we're doing while we're inside this loop where length equals 3 and we're iterating with I, we're just going to increment I, increment j, compare those two. Increment I, increment j, compare those. Increment I, increment j, compare those. Increment I, increment j, compare those. And then once you move I to a position that is greater than n minus length, then you increase length to 4. Move I here. Set j now, instead of being so 1 or 0 plus 4 minus 1. So now you're starting at 1, 2, 3. So now you're always comparing basically the last and the first character. And the way that you know if the last and the first character, if the substring within those two characters are true, let's go back to length equals 3. Like, let's say we're still on the first iteration. So we're just starting off. I is 0, j is 2, right? We're comparing string I with string j. If those are the same, what we want to do is we want to check to see if the character at I plus 1 and j minus 1 was a palindrome. And so if I check I plus 1 is 1, so it's this array right here. J minus 1 is also 1, so it's this element right here. And that's a truthy value. So since that's a truthy value, we know that the element that's inside of the current ij substring of length 3 was also a palindrome. If it is a palindrome, then we can also say that I and j are a palindrome. If it's not a palindrome, then that means that I and j is not a palindrome either. So for this example of length 3, if I and j are the same, we know it's going to be a palindrome because there's only one character in the middle. Of length 4, that's a different story though. That's where it changes a little bit. Now let's say we're at this position where I is actually let's run through this. So we have I is at 0, j is at 2. We check the I plus 1, j minus 1 position. So I plus 1 is the first array, j minus 1 is the 1, and you see this is truthy. And so what we do here is, since we know that ABA is a palindrome because the I plus 1, j minus 1 position of DP is truthy, then we store the length in dpij. So ij is 0, 2. So this is our 0, and then our 2. So we put 3 right there. And now we know that if we're analyzing the entire string, that the first 3 characters is a palindrome of length 3. So we continue moving through here. BAB, same thing. This is also a palindrome. And so these two are also matching. And so we check DP I plus 1, j minus 1. I is 1 at this point. So 0, 1. So we check 2. And then we check j minus 1. So j is at 3. So minus 1 equals 2. So 0, 1, 2. It is indeed a truthy value. And so at dpij or dp13, we also place 3 right there. So we're slowly building out. Now you could see if we're analyzing a substring where I starts at the position of 1, because this contains the information of when I is at position 1. This contains the information of when I is at position 0. This contains the information of when I is at position 5. You know what I'm saying? So this is simply just telling you, each one of these arrays is just telling you basically the position of I. So we have that, then we move it forward again. We have AA, same thing. So we're at position 2 and 4 now. So we do 2 and 4 would be 3 as well. Move it up again, B and B. So now we're at position 3 and 5. So 0, 1, 2, 3, and 5. We change to 3, and then A and B. These are not equal, so that just doesn't matter. And then we have basically what we need there. When length equals 4, we're doing 0 plus 4 minus 1, so 0, 1, 2, 3. In this case, I don't think we have any matches. A, B. Actually, we do have a match right here. We have a match when we're checking all the substrings of length 4, and I is on position 3, J is on 3, 4, 5, 6, J is on 6. Then we have matching B and B. So what we do is we check I. So I is on 3, so 0, 1, 2, 3. J is on 6, so we check 6 minus 1, 0, 1, 2, 3, 4, 5, 6. Actually, this shouldn't be B, A, B, B. 0, 1, 2, 3. Oh, 4. Because I plus 1. So 0, 1, 2, 3, 4, 5, 6. Minus 1. It's falsy. So that's how you know. Like right now we're analyzing this one right here. But since this value right here is falsy, then you know that this is not a palindrome. Otherwise this would be, that would mean that these two were similar from the beginning. So this would be a 2. And then you'd be good to go. But then we increase to 5. I believe there's a, I'll just do, this would be the last one because I'm pretty sure you get this, but 0, so 0 plus 5 minus 1, so 1, 2, 3, 4. So in this case, we're checking I plus 1, so 0, we're checking the 1. 0, 1, 2, 3, 4. So we're checking 4 minus 1. 0, 1, 2, 3. There is a truthy value here. And so we're going to go ahead and take length. And we're going to store it at I, J. So 0, 4. Length 5. And so you just continue building this out here. And so what the final result is going to end up being for this one is, I believe, 5 when we start in the second character. So this is the one that represents when you start in the second character. We have one here. So we'll actually be setting that to 5, like down the road, like a couple iterations forward. And so we'll end up with this one here. But let me go ahead and type a little bit. So we start with our J. What we do once we have J is we're just checking to see if string I and string J are equal, and if the substring inside of SI and SJ were equal. And we check that by checking dp I plus 1 and j minus 1. And if this is a truthy value, then we know that the substring inside of si sj was also a palindrome, and then so we could say that this was also a palindrome here. So we would go ahead and say if si equals sj, they have to be matching first before anything. If they are matching, then we know that this is potentially a palindrome, but it's not a palindrome unless the characters that came first were also a palindrome, because we're working from the inside out. And so we would do dp I plus 1 j minus 1 is not equal to 0. You don't have to do is not equal to 0. I think you could just do dp I plus 1 j minus 1, but this is just like a little bit more clear. And then you would what's up?
I think JavaScript take like 0, like false.
Yeah, exactly. And then if they are equal and the internal characters are also a palindrome, then you just set dp ij to length, and then you check to see if the length is greater than the max length we currently have stored. So if length is greater than max length, then we set a new start position based on the I index, and we set a new length of longest palindrome. So max length equals length. Start equals I. So new starting position is I. And then I believe we could just return after all of this. It would be s.substring start and start plus max length. So our starting position, and then our starting position plus the length of the string. And that should give us our answer right there. Let me test it out and see, make sure. And let me print it too, so we can see what the final version is. There we go. Yeah, so it ends up being this one. And then you actually have all the information. You could even count the palindromes, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 palindromes in this. And if you really wanted to count them on the way, because counting them is actually another problem, you would just do, you have like a count variable and increment count right there, increment count right here, and increment count right here. That's another problem we'll probably come across eventually, but yeah. Does that all make sense?
Yeah.
Cool. What questions do you have? This one was this one took me a while, bro.
No, I think you find this recursion a way to relate something like can I say this? It's something like a function, like to identify your smaller problems with this dpi plus 1 and j minus 1. Yeah, you are doing that and just solving your subproblems. That's great.
There is a recursive solution though, right?
Yeah, but I think that's the idea of dynamic programming. Just like break this into smaller problems and do the combination of these problems to get the main solution.
Exactly. That's basically what happened here. Is we solved for every character first, and we stored that information. Then we solved for two characters at a time, and we stored that information. Then, based on just having this information, we were able to solve the rest, building from smaller problems into larger problems.
Yeah, we
Yeah.
start with 1, 2, and 3, and so on.
Yep. And just moved your way up.
But I think this takes a lot of time when you try to figure out that problem. Out.
Yeah, it's still tough to think about, even like coming from the problem from the beginning, like without having solved it. It's like, man, how do you come up with the solution? You know, how do you go from not having the solution to having the solution? You know, that's really the hard part for most people. I want to do it. I want to do it with the recursive though. I'd like to try that as well.
Yeah, but yeah, recursion. You can divide your problems like a tree. It's something like a tree, and you can um, say that each branch is like some kind of division or some kind of problems.
Mm.
But for me, the difficult part on the dynamic programming is solving without using recursion. It's just thinking about the smaller cases and do the combination
Mm-hmm. Mm-hmm.
to build the yeah
Ye-
solve the big problem.
Recursion would be much less code though. So much simpler. But recursion is a little bit sometimes hard to wrap your head around too. I like Moniker's algorithm so far. Just the fact that it's the most efficient of all the solutions for this one. I'm excited to jump into it on Thursday.
Yeah, the more efficient, but the more complex at the same time.
Exactly. Exactly. But it's cool because at least the way I was going over it, yeah, I think it's actually simpler than the dynamic programming solution, to be honest with you.
Mm. Oh, yeah, it could be.
I feel like it's more straightforward. You know, you just have one array to store the information you need instead of a matrix, and then you have five main pointers, but uh, yeah, it seems definitely more straightforward. It's interesting because it's wild how like you have your eye, and then you have the mirror. You have your center, so like the center, and then you have your eye, and you have your M. And if your I or your current position is less than the right boundary, you do something. If it's greater than the right boundary, you do something else. And then, yeah, it's just interesting. I have to dig through it a little bit more. I don't really fully grasp it 100%. Maybe like a couple more hours, I'll be like, okay, this makes sense now. But it's still challenging. But I think if I gave this one as much time as I gave the dynamic programming one, then it would actually make a lot more sense. I think it's easier
Yeah,
than it seems.
I was reading that it's something like it it helped you to find some palindromes inside other biggest palindrome, and so it's building their solution, uh, connecting these subpalindromes, so it's reducing in that way.
Mm-hmm. Mm. Yeah, yeah, it's gonna be fun. It's gonna be cool. I'm spending most of tomorrow going through machine learning stuff. So we have the machine learning mastery club. I'm starting that back up tomorrow. We'll see. We actually have a lot of reservations from meetup, so we'll see how that goes. But I'm I'm focused on just reading this. So whenever they mention a scholarly article in the book, I'm gonna actually take the time to read it and actually break this down the same way that I break down like the dynamic programming algorithm and Moniker's algorithm. Like I actually want to take my time and understand this stuff on a deep level. I don't want to rush through stuff anymore, because when you rush through stuff, you don't really understand it on a deep level. And man, if you just slow down your speed even half the speed, you just take in so much more, you know. And with this kind of stuff, you can't rush, man. You can't rush. You just have to take your time and really understand it inside and out, and not just what it is, but how it works and why it's important. You know, like the whole 9 yards, everything, man. Like learning is difficult in densely connected, directed belief nets that have many hidden layers, because it's difficult to infer the conditional distribution of the hidden activities when given a data vector. Like, bro, what is a densely connected directed belief net? What is a belief net? Let's start with that. Now, what's a directed belief net? What's a connected belief net? You know, like actually understanding what this means before moving on to the rest of the sentence. With stuff like this, bro, if you don't ever break this down and dive deeper into what this stuff actually means, then you don't even understand the next sentence. So what's even the point, you know?
Yeah.
And this is what everyone's looking for these days, man. Like, I know it sucks to hear that interviewing is slowing down and less big companies are hiring for software engineering and those sort of roles. They have a lot of tools that are like doing a lot of the coding for people now, even with AI. And it's, I could see right now that the fastest growing, at least from what I hear, I listen to a lot, I read a lot, is machine learning and virtual reality and augmented reality. Those are the ones that, like, if you're a software engineer and you already have those software engineering skills, those are the two that will be the most seamless transition to. Sure, there's things like robotics, you know, or quantum computing or those other things, but moving from software engineer to one of those is just a much bigger leap. You know what I'm saying? But moving to something like virtual reality, augmented reality, machine learning, that's possible. And that's kind of what people have to do right now. Otherwise, they're just not going to have a job or the skills to get a better job soon, you know?
Yeah. Like you have to immerse in these new skills.
Yeah, exactly. Exactly.
Yeah, that's one reason that's why I'm learning Python. But yeah, I need to dig in also machine learning and that stuff, because I didn't start with that topic.
Yeah, feel free to read this book with us if you want. I'll show you the book. We're going to meet every Wednesday and just go over this. So hands-on machine learning with scikit-learn, Keras, and TensorFlow. There's a bunch of other good books, but this is like the main one. This is, you ask anyone, which one should I read first? It's this one right here. So
Yeah, I saw that book. This is the popular one book to start.
Yeah, feel free to join us if you want. Cool. All right, I'm gonna take a little break before the next event start. I got another one coming up at 8 o'clock. I'm going over binary search trees today, so feel free to hop into that if you want to.
Okay, nice.
Cool.
Thanks for the explanations today.
Yeah, for sure.
I didn't think in the dynamic programming approach. Just I was immersed in this Moniker's algorithm, but yeah, I like it.
Cool. Yeah, we'll go over Monikers on Thursday. That'll be cool. All right, I'll see you soon.
Okay, see you soon.
Peace.